In this video, we're going to look at dividing polynomials by a single monomial. As a starting point, we'll look at something that we have already learned how to do, taking a linear equation in two variables that is in standard form and solving it for slope-intercept form. So in part A, we want to solve the equation 4x plus 2y equals 12 for y, which is essentially putting it into slope-intercept form. Since we want to solve for y, our first step is to remove the 4x from the left side. Since it is a positive 4x, we will subtract 4x from both sides of the equation. Once we subtract that 4x from both sides of the equation, the resulting equation will be 2y equals negative 4x plus 12. To finish solving this equation for y, we need to eliminate the coefficient on the y. Since it is currently 2y, we recognize we need to divide both sides of the equation by 2. On the left side of the equation, 2y divided by 2 gives us y. To carry out the division on the right-hand side of the equation, the negative 4x plus 12 all divided by 2, we recognize what we need to do is to divide each of those two individually by 2. So we're really going to have negative 4x divided by 2 plus 12 divided by 2. So our final answer for this equation in slope-intercept form is y equals negative 2x plus 6. The reason we wanted to start with this example is because if we take everything away except for the step where we divided both sides of the equation by 2 and really only focus on what happens on the right side of the equation, where we went from negative 4x plus 12 all over 2 to negative 4x over 2 plus 12 over 2, that right there is polynomial division. To divide a polynomial by a monomial, we simply divide each term of the polynomial in the top by that same monomial that's in the denominator. So let's take a look at part B of this example, where we're going to divide polynomials by monomials outside of this context. In example B, part 1, we have 4t to the third plus 8t squared minus 6t, all divided by 2t. What we need to do to carry out this division is simply divide each of the terms in the numerator by that 2t. In the beginning, we'll practice writing this out step by step. As we become more comfortable, we won't need to write as much of this out by hand. So our first step will be to take 4t to the third plus 8t squared minus 6t all over 2t and write it out as 4t to the third over 2t plus 8t squared over 2t minus 6t over 2t. Once we've split this up into 3 separate division problems, it really becomes a problem of just dividing monomials together. In the front, 4t to the third divided by 2t. Well, 4 divided by 2 is 2, and t to the third divided by t tells us we're going to cancel out one of the 3 t's from the numerator, leaving us with 2. So we'll have 2t squared as our first term, plus 8t squared over 2t. Well, 8 divided by 2 is 4, and t squared divided by t, that t in the denominator cancels with 1 in the numerator, leaving us with just 4t. Then we have minus 6t over 2t. Well, 6 divided by 2 is 3, and t divided by t cancels, leaving us just with a 1. We don't need to write 3 times 1, we can simply write that as 3. So the simplified result of taking 4t to the third plus 8t squared minus 6t all divided by 2t is 2t squared plus 4t minus 3. In part 2 of this example, we have 9x to the 12th minus 6x to the 9th plus 12x to the 6th, all divided by negative 3x to the 6th. Again, as a starting point, we will separate this really into 3 separate division problems, but as we do this, we might be inclined to work out the signs from each of those pieces. What I mean by that is when I write 9x to the 12th over negative 3x to the 6th, I recognize that a positive divided by a negative will be a negative, and then I will have 9x to the 12th over 3x to the 6th. When I go to the second term in the numerator, negative 6x to the 9th, and write that over negative 3x to the 6th, I'll recognize that a negative divided by a negative is a positive, and simply write 6x to the 9th over 3x to the 6th. And on the last term, we have plus 12x to the 6th divided by negative 3x to the 6th. I'll again recognize a positive divided by a negative is a negative, And up in the numerator, I still have 12x to the 6th, and in the denominator, the same 3x to the 6th. The final step is now carrying out each of those individual divisions. In the first term, we know it's a negative. We have 9x to the 12th divided by 3x to the 6th. 9 divided by 3 is 3. X to the 12th divided by x to the 6th is x to the 6th. For the second term, we know it's addition. We have 6x to the 9th over 3x to the 6th. 6 divided by 3 is 2. X to the 9th divided by x to the 6th is x to the 3rd. And the final term, we know it's subtraction. 12x to the 6th over 3x to the 6th. 12 divided by 3 is 4, and x to the 6th over x to the 6th cancel. That leaves us with a 1, but we don't need to write 4 times 1 because 4 times 1 is 4. So the final result of 9x to the 12th minus 6x to the 9th plus 12x to the 6th all over negative 3x to the 6th is negative 3x to the 6th plus 2x to the 3rd minus 4. The more practice you get with dividing polynomials by a monomial, the more you'll start to become comfortable doing that middle step, that first step we did on paper, in your head. What I mean by that is, instead of writing, for example, b part 1, 4t to the 3rd over 2t plus 8t squared over 2t minus 6t over 2t, you'll start to do that step in your head, and you'll simply mentally connect up. Oh, 4t to the 3rd divided by 2t gives me 2t squared. 8t squared over 2t gives me 4t. And negative 6t divided by 2t gives me negative 3. It is important in the beginning to write that step out, to really understand that you are distributing dividing by 2t to each of the terms up in the numerator. But as with a lot of math, the more comfortable you come doing it mentally, the less you need to write on paper. And a lot of these division problems will ultimately become a single-step division problem where you don't show that thought process that we have originally written on paper.